Hi, in this video we're going to prove that an algebraic expression is always either even or always odd. So we're told that n is an integer. Integer just means a whole number, and we want to prove that this expression here is always even. Now basically, if a number is always even, then it can be written in the form 2 multiplied by something. The reason is because 2 multiplied by anything is always guaranteed to be even. For example, if I had 2 times 5, that's 10, which is even. If I had 2 times 6, that's 12, which is even. So 2 multiplied by any integer is always going to be even. And even if I had, for example, 2 times an algebraic expression, like 2 times n plus 1, for example, then provided that this is a whole number, the n plus 1 is a whole number, then 2 times it would still be even, right? For example, if n was 1, 1 plus 1 is 2, 2 times 2 is 4, which is even. If n was, say, 5, 5 plus 1 is 6, 2 times 6 is 12, which is even. So provided that n is a whole number plus a whole number is a whole number, and 2 times a whole number would be even, right? So that's the form that we need to get something in to show that something is even. So let's expand this out here because we want to show it can be written in this form here. So we've got, let's just move this down a bit so it's out of the way. 2n minus 7 squared, well, we can just write that bracket times by itself to square it, minus 9. Let's expand out. So we do each thing in the first bracket times by each thing in the second. So we do 2n times 2n, which is 4n squared. We do 2n times minus 7, which is minus 14n. We do the minus 7 times the 2n, which is minus 14n. And we do the minus 7 times the minus 7. Negative times negative is positive. We get plus 49. We've still got that minus 9, minding its own business on the end. Now let's just collect like terms. How many n squared terms we have? Well, this is the only n squared term. So we're just going to put 4n squared. How many n terms do we have without the squared? Well, I can see I've got the minus 14n minus 14n. That's minus 28 lots of n. And then we've got the 49 minus 9 on the end, which is plus 40. Now, we said to show that this is even, it has to be written in the form 2 times by something. So 2 with a bracket after. So we just need to factorize a 2 out to show that it can be written as 2 times something. So if we do that, 2 times something, 2 times what is 4n squared, well, it's 2n squared. 2 times what is minus 28n, well, it's minus 14n. And 2 times what is 40, which is plus 20. So we factorize out the 2, and therefore, because it can be written as 2 times a whole number, we know it's therefore even. So we can write therefore, that's the therefore symbol, 2n minus 7 squared minus 9 is always even. In general, whenever you have any prove that statement, so it says prove that blah is always an even number, you should finish your proof with therefore, and then just restate that thing. So therefore, 2n minus 7 squared minus 9 is always an even number, which is what I've done there. Okay, right, what about this one here? We want to show that this is always an odd number. Now, an odd number can always be written as 1 more than an even number. For example, 7 is an odd number. It's 1 more than 6, which is an even number. And that means basically an odd number can always be written in the form 2 times something, which will be an even number, as we saw earlier, plus 1. So an odd number can always be written as 1 more than an even number. So using that, we're going to show that this can be written in this form and therefore is always an odd number. Right, so let's expand this. We've got 2n minus 1 times 4n minus 3 plus 4. We want to show it's always odd. Let's expand it out. So we do each thing in the first bracket times each thing in the second. So 2n times 4n is 8n squared. 2n times minus 3 is minus 6n. We've got minus 1 times 4n is minus 4n, and minus 1 times minus 3 is plus 3. That plus 4 is there just minding its own business at the end. Let's collect like terms again. We've got 8n squared. We've got minus 6n minus 4n, which is minus 10 lots of n. And we've got the 3 plus 4, which is plus 7. Now, we said we need to write this in the form 2 times something, some bracket, plus 1. Now, we don't have plus 1 on the end, but let's just split the 7 into 6 plus 1, because now we have this plus 1 on the end here, right? So now we just need to just show we can write the rest as 2 times something. We're going to factorize 2 out the rest of it here, yeah? So let's do that. 2 times something plus that 1 at the end. Now 2 times what is 8n squared? It's 4n squared. 2 times what is minus 10n? It's minus 5n. And 2 times what is plus 6? It's plus 3. So I've written this expression in that form, and therefore it's odd. And as I said before, because it's a prove that question, prove that blah is always an odd number, I can just write that. So therefore symbol, 2n minus 1, I'm just copying what's at the top, 4n minus 3. Sorry, that's minus 3. Plus 4 is always an odd number, so is always odd. And we're done.